So I think I will start, if everyone is here. So I will talk about continuous delivery. Does anyone else what continuous delivery is? Okay, that will be interesting. Does anyone else what is continuous integration? Okay, great. Okay, so I'm Gediminas Guoba. I work as software architect at Adform, and last my 4, maybe 5 years, I spent a lot on automation, about automating different stuff during development process, like automate testing, automate deployment, automate packages, and so on, automate everything. So just to understand how big our company is and what it wasn't just single application migration to continuous delivery. I have put one slide about how big Adform is. So basically we have 300 physical servers on 2 different data centers located in Copenhagen. I don't know how many virtual servers we have, so just physical servers. We are serving, by the way, Adform just is a serving company. We are serving banners. So we are serving about 70,000 banners per second, and we have more than 65 different applications to provide a service to our clients. So we're quite big, I think. We have started, or we have decided to move to continuous delivery about 2 years ago, and we got a really great experience during that period, and now I want to share that experience with you. So a few years ago we started to use Agile at Adform, and okay, since then we became Scrum gurus. We started to monitor our performance, our team performance, and we find out that actually we do not perform very well. So we find out that about only 50% of usual sprint we are spending for development. So if your sprint is 2 weeks, so we only spent 5 days for development. Other days, okay, other 2 days went for Scrum ritual, so that's okay. But other 3 days go for manual testing, manual package preparation, manual deployment to each environment, regression testing, and so on and so on. So basically that's a huge amount of time went for, I would say, for routine tasks, yeah? So would it be nice to eliminate somehow that 30% and spend more time for development, for fun things, yeah? So could you imagine what you are spending in place of 5 days, 7 days of development, or even 8 days for development, and other time you will spend only for Scrum rituals like planning, retrospectives, and so on? So yes, that would be great, because that additional 2 or 3 days per sprint is about from 40 to 60 additional development days per year. Actually, that's a huge amount. So, okay, after finding that, we have decided, let's go to continuous delivery, because we read a lot of clever books which says that continuous delivery will help you. So what makes difference? Continuous delivery makes different from other methodologies. So basically, before continuous delivery, your development process is something similar to carrying bucket. You just carrying bucket, putting some water in it, going and flushing. In place of that, if you using continuous delivery, it's something like to use a hose. In place, as I said, carrying a bucket, you just throwing water continuously. So, okay, that sounds good. How to achieve continuous delivery? Basically, to achieve continuous delivery, you should implement at your development process some quite simple things. Okay, it looks very simple. The first one, source control. I think everyone uses source control. I hope so. Next thing, continuous integration and things like unit test, functional test, UI test, integration test, API test, whatever test what you want, and everything that run inside continuous integration tool. Next thing, you should implement automated build and releases. So basically, you can use the same continuous integration tool, or in other words, CI tool. You should automatically build your package and automatically release, for example, to test environments, to stage environments, and to prod. So, and the last thing which you should implement is monitoring. So, if you think that your application runs correctly in production and it still runs, what it says, how you could tell that it still runs, that it's still working. So basically for that you need to implement a monitoring. So that stuff looks quite simple. Some time ago, Urban Code, the very big continuous delivery consultancy company, have published a slide where they have separated continuous integration maturity model into several levels. So what does it mean? It means that if you are using, for example, source code, so you basically somewhere in the introductory level. If you have implemented automated deployment to testing environments, so you somewhere in intermediate level. But if you have decided to implement continuous delivery, you are insane. So, okay, we didn't say that to our management, and don't tell, and I recommend don't tell your management too. So what we did in Adform, we just go insane. And we have decided to, okay, let's implement continuous delivery at Adform. So the bunch of developers, the bunch of architects, actually there was 4 of us, we have started to implement tools and recommendations and practices to our colleagues how to implement continuous delivery at Adform. So after 2 months, we got custom configuration storage, just where we were storing our configuration data. We have built custom package storage, web service based, but in any way it's custom, where we were storing our release packages. Also, we prepared sample scripts how to automate our package build and how to automate deployment to servers. Also, we implemented sample how to test UI and so on and so on and so on. So, okay, everything that we did on Windows, so we became PowerShell gurus. I don't know, does anyone know what does it mean? And the last one, we even have automated virtual machine manager, which actually it's close to impossible, but we did it. So, okay, we did a really great job going to continuous delivery, and we have presented all that thing to our development. And actually, we failed. What does it mean? Does it mean development said, come on, guys, that's too hard to implement, that's too hard to achieve, that's too hard to think about that at all. So, okay, we failed, but actually that wasn't a big problem. After a few days, we started again. Something throwing away, something starting to develop from the scratch. But at that time, we understood the theory which we have read in the books. The theory says that continuous delivery stays on 5 pillars. There is some very important things which you should achieve before going, or okay, maybe not thinking, but before going to continuous delivery and starting to implement it. So the first pillar to achieve continuous delivery, and the most important, is culture. I haven't written here a lot because I will talk about culture in every next slide. The culture, how your team works, how your team does your team respect each other, how we take responsibility what we do. All that things is about culture. I will tell you one sample. When we did first presentation of continuous delivery, we told to everyone, okay guys, we are going to make a continuous delivery, and when we will finish it, everyone will be able to release the pod to production. Can you imagine 100 developers releasing to production? So yeah, everyone said, of course you're insane, you are crazy, it will never happen, and so on, and so on, and so on. And developers and operations, everyone agreed that that is impossible. What we have now that developers can release to development. I will tell you how we have achieved it, but we have such situation, and that's okay. That was natural way when end operations and developers said, okay, let's then release. So, culture. Next thing, what you must achieve is test-driven development, or in other ways, in other words, start to writing tests. So how many of you working in some kind of TDD? Okay, you have a lot of work. So what does it mean, at least? If you want to have continuous delivery, or okay, it's insane and you don't want to have it, but in any way, testing is the very long phase in the sprint, and it takes really a lot of time in place. When you are debugging your code for bugs and so on, in place of that, you better would write a test. So if you so in place of testing manually, what we have started to do in Adform, we have started, we said, okay, that's enough for manual testing. Let's start to write unit tests, integration tests, UI tests, and so on, and so on, and so on. So make our system fully coverable with tests, just to make sure that, okay, every time when we will release something, everything works and works correctly. So that's not easy to achieve, especially for legacy code. And again, talking about culture, when we say that we will write UI tests, we will write integration tests, we hear things like, well, it's impossible, we have a lot of legacy code which is untestable, which is hard to test, we don't know how to do that, we use tools, and so on, so on, so on. Actually, there was a lot of excuse why we can't achieve this. But now, the same people, the same guys, talking completely differently. They are saying like, we are talking like, okay, that code part is poorly covered, so let's implement more tests, let's implement integration tests, let's do some automation, and so on and so on. The mindset, the culture during the 2 years completely have changed at Adform, and that's completely different Adform. So if you don't have even single test, that's actually easy to start. Just write your first test. It doesn't matter, is it unit test, is it UI test, or whatever test. I guarantee to you that it will be hard. It will be hard to start. It will be hard to implement. It will be, maybe once you will say that's all, I will stop. I don't want to write any more tests and so on, because writing tests is hard, yes. But with experience, you will find that it is easier and easier, and you will see how your mind changes with your experience. And actually, writing tests is really a rewarding thing. I hope one day you will feel like we're feeling now, when you know what, if you run tests, test of your application, and it says green, that means everything is okay. You find out what, yeah, of course, everything is okay. And if you run test and it says that something is wrong, you find out, yeah, there is really something is wrong. After that, you will start to trust your tests, and you will find that you're doing less manual work. You're just starting to trust your tests. You're just starting to write more tests to cover more and more functionality of your application. So there is one good thing how to start and how to move to automating your tests is just say no manual testing anymore. And one my colleague some time ago told me very good phrase, which I like very much. He said, okay, him invited to, could you please test to us one application? We want to release something and so on and so on. He said, do you have automated tests? We said, no, we don't. And he said, I have allergy to manual testing, so at first I will write automated test and then I will test with that automated tests. So yeah, I like it. So I wish you everyone to get some kind of allergy to manual testing and find out that automated testing way. Some of you who have raised the hand already knows what continuous integration is, at least maybe you using it. So you must have some kind of integration, continuous integration tool to automate everything about what I'm talking here. So, automate checking out from your source repository, automating checkout, automating build of your application, automate unit test running, automate package preparation, deployment, event deployment, and so on and so on. That's must-have tool to go to continuous delivery. In any way, if you remember that slide where it was written that continuous delivery is insane, that's okay. You can go to intermediate and still implement it and bring more automation to your development process. The next thing, you should have a configuration management tool. What does it mean? It means that when you are releasing, usually you are releasing to stage environment or for testing environment, and just then you are releasing to production environment. So to make your release package a single unit which doesn't know the configuration of each your environment, you should have configuration management which holds information about each environment, at least about IPs, maybe folders where your application should deploy, and so on and so on. And the last thing, but very, very important thing, what you should implement if you want to go with continuous delivery is immune system. You should build immune system, you should build immune applications to get your system immune. So there is just few patterns how to achieve. So basically, imagine if you are releasing your application during the day, I think your client will be not very happy if you will say, okay, let's stop work, I'm doing release, everything now closes, and that's all. Let's go to take some coffee break or something. So in place of that, your system should implement some gentle version switch. And actually, we use two patterns of it. If we have more than one server, we are just switching one server off from the service and deploying our new application and then switching back. If we have just single application, we just deploying new application to new folder and then switching that two applications, and that's okay. So your application deployment must be quite clever to to handle such situations when, for example, during release you have failed, you have got, for example, file lock or something and your release failed. So your release should be quite clever to handle it and don't show error message to your client. And the last thing which is very important to immune system, again, you should implement monitoring system. You should monitor if your application still works, if it performs well, if it, I don't know, if it does what it's supposed to be do. So now I will go through the continuous delivery process and tell you a little bit about tools which you can use implementing continuous delivery or at least continuous integration at your company. So usually the process of continuous delivery looks like that one. So basically what you do, you're committing some code to the source control. Later, continuous integration tool brings that source code, builds, runs unit test, integration test, other test, builds the package, uploads to repository, then deploys to some server, runs smoke test just to be sure that your application has been deployed successfully, and later you just monitor it. So what tools to take and what tools I can recommend in each part going with continuous delivery. So the first thing for source control. There's many source control systems, so maybe the oldest one is SVN or even CVS, if someone remembers. So at Adform we use SVN too, but we are massively moving to JIT. And actually with JIT we are using GitLab too. Does anyone knows what GitHub is? Okay, that's great. So GitLab is something what you can run at your company. It's something like GitHub, what you can run in your company. It's open source layer, it's open source social layer on JIT. So actually when we started to use GitLab, we find many very useful features, like I'm talking about social features like wiki, like issues, like merge requests. So basically even the small application now can have its documentation related to project. Even small application can have issues list, and actually we find it very useful. And of course the merge request with SVN we didn't use very well code reviews. With GitLab we started to use merge request where one developer works on separate bunch and later it says, okay, I have done, I want to merge to the master, and sends merge request to someone who does a review, approves it, and merge it to the master. So basically GitLab with its social layer bring bring better code review to our company. Next thing is, of course, continuous integration tool. In the previous presentation, you have heard about Jenkins. Actually, it's my favorite too. So if you're just starting with continuous integration, go with Jenkins. I'm sure you will be lucky and happy. Actually, Jenkins is #1 tool, CI tool in the world, open source tool, and it has more than 400 different plugins for different purposes. So yeah, it's really good tool. Another open source tool is BuildBot. Actually, it's very advanced tool. It's very advanced tool, and it uses BuildBot is used by such teams like who builds the Linux kernel, who builds MongoDB. So actually it's very serious tool, but if you're just starting with continuous integration, please don't take it. Just. And okay, the old one, Cruise Control. I think most of you know it. On top of release control, there is a lot of different tools built, for example, like Go. By the way, Go and TeamCity is paid into continuous integration tools, but they have some kind of free license. So basically one or other can provide you 2 agents on which you can build. But by the way, at Adform mostly we use TeamCity, and just for some kind of automation in our integration environment we use Jenkins too, a little bit. So for build, you can use anything dependent on your platform. If you're on .NET, use MsBuild, Ant, and so on. If you're on Java, use Maven and Gradle. It depends completely on your platform. Every platform has continuous integration tools for continuous integration. For unit test, again, depending on your platform, use anything what that platform provides. If you're on .NET, use NUnit. If you're on Java, use JUnit. If you're on JavaScript, use anything what you want. There is a lot of different frameworks, and all they works and works really great. For integration tests, again, basically, integration tests is talking about on which environment to run integration tests. So it depends. If you are a big company, you have separate environments, run in separate environments. If you want to do some kind of automation for restoring environment, for restoring clean environment, you can use tools like Microsoft VMM, which you use, by the way, or the same Jenkins has VMware plugin. With help of that plugin, you can just restore your virtual machine, which you have prepared earlier, and run integration tests on it, and later just shut down it. For other tests like API tests, like UI tests, and so on, you can use, again, anything dependent on your platform. But for UI test, I think the #1 in the world is Selenium WebDriver. And by the way, remember, if you haven't written any UI test and you don't know what Selenium is, remember that word WebDriver, because that is the new version of Selenium, which is based on completely new architecture, which helps much easily to write a UI test. So if you are starting with UI test, go with Selenium WebDriver. And later, after your package is built, after your application is built, after your all tests, unit test, integration test, and whatever test have passed, you can upload it successfully to some of repository from where you will take your package and will deploy to the server. For the repository, you can use Nexus or Nugget. It doesn't matter. It basically depends on the platform which you use. Or you can use any HTTP or network storage. It doesn't matter. Next, to deploy your application, as I told you previously, you need some configuration information about how to or where to deploy your application, what IPs is of your servers, to which folder, connection to database, passwords, or anything, and so on and so on. So configuration management tool, you can choose starting from just simple source control. By the way, we at Adform use just simple source control. So basically, every changes to every environment, we just committing to source control. And during release, we have made some tools which we can easily access that information and use during core releases. Other very simple tool I have written here, but it is important. It is unsupported since 2009, but actually it's very simple tool, and many people use it. So that's basically is very simple. You just define some environments, for example, staging, testing, production, and so on, and just putting key values, storing all your configuration management. If you are a bigger company, if you know or your at least operations know Puppet and Chef, go with Puppet and Chef. That is very big, very useful, and really powerful configuration management tools. For deployment, again, you can start from simple build script or shell script, which just copies your application to the place where it is supposed to be. And of course, you can use Puppet or Chef, which is dedicated for such tasks. As I told you previously, to deploy application is not enough. You should know, you should be sure that your application is successfully deployed. So for that, usually after deployment, we run immediately some tests of that application, testing it. So basically it can be just self-check. For example, asking, okay, is it your configuration okay? Do you access some all external resources, for example, like messaging system, database, files, and so on and so on. You can run such tests like unit test. Of course, you can build some tests specially dedicated for production and run just Selenium test, just connecting to your UI, going through UI, maybe trying to enter some data, save, and in that way be sure that your application is deployed successfully and it works correctly. And the last thing is monitoring. Basically, you can say that monitoring and monitoring tools is not for development, but my colleague today during one of presentations, I think explained why it's not, why developers should care about monitoring too, and why we do at Adform, why we using monitoring and how we using monitoring. So what I can say, to start to use monitoring is not a hard thing. Maybe the hardest thing is to choose the tool. Here you can see 4 tools, all of they are open source and all of they do the job. At Adform we use Zabbix. Actually, maybe it's one of the most kind of user-friendly tools comparing with others. So how you should use monitoring and how you should start to use monitoring. The first thing, start to monitor, for example, CPU and memory of your server, just to make sure that everything goes okay, your application doesn't consume a lot of memory and so on. Later go to monitoring of your application, like concrete application, CPU and memory. Later, implement some metrics in your application and monitor it. For example, how many requests it got, how many errors it have provided, and so on. Based on that metrics, later you will be able to implement as we call triggering, event triggering. So basically you will be able to configure if error count has been increased, for example, for 10 errors per past minute, send me an email, I want to know about that, and I will go to fix it. So we use monitoring for such things like to be sure that your application is running, to check different things, and to check that it performs really well. So, and final word about continuous delivery is continuous delivery implementation is continuous process. You can't, at least I think so, you can't say that, okay, we will develop, we will go to continuous delivery through the next year or I don't know, maybe month. You can't say so because even now, when we have reached when we made a quite huge step in automation, we have a lot of things to automate. And from day to day, when we're going, we are learning more and more things what we want to automate and make it faster. So that's continuous process. Another thing, don't try to implement everything at once, because actually that's a huge job, first. Second, some things I think will not work. You should implement, for example, a small thing, for example, automated building. You should try to use it for a week or two. You should, if you will feel that it really works great, it lets you spend less time for that job, so that's okay. You are on the right way. If it's not, if you are feeling like it's consuming even more time, so drop it. Just drop it and start again. And finally, talking about everything, going to continuous delivery, just automate everything. Automate testing, automate builds, automate deploying, automate whatever you can. All routine tasks could be automated, so just do that. And now, Adform, after 2 years, we have completely automated package preparation, testing, and registration for release. So basically now when developers commits a code to a repository, it builds automatically, runs tests, many tests, and it will be registered also to our release dashboard. We have implemented different types of tests, and basically with each new project or even each day we are finding new types of tests. So basically if 2 years ago we know about unit and integration tests, now we do API different tests, UI different tests, even JavaScript tests, and so on and so on. Next we have release dashboard, where anyone can just click a button and say, okay, that release I want to have on that environment. Actually, I have a slide of it. Yeah, that's our custom tool. Yeah, we have built a custom tool, but I don't recommend to do that because actually it takes a lot of time. It takes a lot of time, and especially it takes a lot of time for infrastructure to move a package to desired server, to run it, to collect logs, to handle errors, and so on and so on. Actually, it's hard work. So here's our release dashboard. What you can see here is some different releases. Here are different environments, and developer who is developing can just click deploy, and that release package will be deployed to that environment. If something goes wrong, of course, a developer can go to see a log and fix that problem. So, yeah. And actually, we like it, that tool very much. We like it as much that we even have built some facts about it. So, some kind of releaser, by the way, that application called is releaser. Some kind of releaser runs on potatoes. Who knows? And we have, of course, implemented company-wide monitoring. That's about what Mantas were telling. And as I said, the last and the most important thing was some kind of target of our continuous delivery was permission to deploy to developers to production. That's all. Thank you. Questions? Yes.
We were talking about the deployment live, about the good system. You were mentioning that you must be able to do a gentle switch. Well, it's relatively simple perhaps if your application is a single tier platform and you have several servers. But let's say that you have a web front end which uses some web-service backend and both of them are load balanced. So how would you deploy a gentle version switch if the API between front and back end changes or something? Something like that.
Actually, depends on details of your architecture, but I heard very good keyword load balancing. So basically what we do now, we just switching that server from the load balancing, deploying to it, and returning back after some tests, and that's all. But I will tell you much difficult example of gentle version switch, if I can say so. Recently we had a project where we started to migrate one application to the completely new architecture, and actually that application was very big and we couldn't migrate it through one sprint, but from the beginning we said every sprint will release something to the production. So how to migrate such kind of application and do the sprint and do the release every sprint? What we did, we implemented some version switching module, which was quite clever, which depending on what user has been connected to the system, and if that user goes to the page, actually we did a migration page by page, and if that user comes to the page which we have migrated, that clever version switcher switches to the new application. Then user goes around that application, and when he or she goes out of that functionality which we have migrated, version switcher returns it back to the old application. Even such functionality or such solutions are possible, and it make able us to deploy every sprint, and it make able us to roll back quickly. We had one fail when we find out that we left somewhere a memory leak. So with single rollback, second or two, we disabled that functionality, and all users were directed to the old application. So the limit is only your imagination. Yeah, but at least like with unit test or other test, you should try it do at least once, and later you will know how to do that again. So just try it. The first time is hardest. Yes.
You said you test only with automated tests. How many QA do you have? And what work are you doing?
I will say approximately. We have tester in every team. So basically, if there is a team with 7 members, so one of them is tester. But that's not important, I think, because QA. Okay, at first we tried that our QA started to write where we tried to learn our QA to write the tests. Actually, that was not a very good thing, because we are not developers, we are not programmers. So basically, what should do QA is just say that, okay, that part is poorly covered. We have some issues on that part, so let's plan for next sprint and implement some automated tests for that part. So basically, tests are implemented by developers, not QA. QA are not developers.
So what's the role of QA member?
As I said, the QA role is, as it's supposed to be, just to point and say, here we have a problem. We should improve the quality of that part. So, okay, that's very, just in few words, actually, we do much more, but I do not recommend to ask QAs to develop.
Doesn't that automated test show variants that problem?
Depends on your implementation. Usually, yes, because if you write tests for every feature, you are usually naming tests to naming tests with giving a meaningful names to tests, just to know what if it have broken, it will tell you where that problem is. So that just depends on your implementation. Yes?
Do you write unit tests or unit tests?
I can.
These unit tests are correct.
I can't remember such thing. But if you are doing TDD, test-driven development, basically you don't need that. Because when you are implementing tests, all your tests should fail. And just when you will implement real functionality, all that tests should be green. So basically that's some kind of unit testing of unit testing. Yes?
Is there anything special you do about non-functional and bonus testing?
What do you mean?
Like functional testing is like, not stress testing, but straight system performance. Everything is what's not functional.
We do where it is important, I would say so. And my colleague, when he was talking about metrics-driven development, he was talking exactly about that. How we used monitoring tools to improve the performance of our applications. But we just do where it is important, where it is really important.
What about the automation or something about that, or only monitoring?
Only monitoring.
The parts of the deployment process.
Do you automate your performance testing?
Some kind of. We have scripts which we use to prepare a load. I'm talking about just simple web applications. We use scripts which we use to prepare a load for our servers. So if you're asking if we're writing every time this, no, we don't. We have prepared scripts because that's quite natural for us, and especially for applications which serving 70,000 transactions per second. Okay, so that's all. Thank you, and good luck with continuous integration.